Hey guys, welcome to Rihanna's Lens, where I interact with you about the components in the STEM field and introduce you to fascinating people who passionately inhabit the scientific and technical frontiers of our society. My name is Rihanna Malhotra, and I'm absolutely elated to share this podcast with all of you. Sending rockets into space requires sacrificing expensive equipment, burning massive amounts of fuel, and risking potential catastrophe. So, in the space race of the 21st century, some engineers are abandoning rockets for something much more exciting. Yes, you did read the title right. Elevators. So maybe riding an elevator to the stars isn't the most thrilling mode of transportation, but using a fixed structure to send smaller payloads of astronauts and equipment into orbit would be safer, easier, and cheaper. On a SpaceX Falcon 9 rocket, every single kilogram of cargo costs roughly around $7,500 to carry into orbit. Space elevators are projected to reduce that cost by 95%. Researchers have been investigating this idea since 1895, when a visit to what was then the world's tallest structure inspired a Russian scientist. This scientist imagined a structure thousands of kilometers tall, but even a century later, no known material is strong enough to support such a building. Fortunately, the laws of physics offer a promising alternative design. Imagine hopping on a fast spinning carousel while holding a rope attached to a rock. As long as the carousel keeps spinning, the rock and the rope will remain horizontal, kept aloft by centrifugal force. If you're holding the rope, you'll feel this apparent initial acceleration, pulling the rock away from the center of the rotating carousel. Now, if we replace the carousel with Earth, the rope with a long tether, and the rock with a counterweight, we have just envisioned the modern space elevator, a cable pulled into space by the physics of our spinning planets. For this to work, the counterweight would need to be far enough away that the centrifugal force generated by the Earth's spin is greater than the planet's gravitational force. These forces balance out at roughly 36,000 kilometers above the surface, so the counterweight should be beyond this height. Objects at this specific distance are in geostationary orbit, meaning that they revolve around Earth at the same rate the planet spins, thus appearing motionless in the sky. The counterweight itself could be anything, even a captured asteroid. From here, the tether could be released down through the atmosphere and connected to a base station on the planet's surface. To maximize the centrifugal acceleration, this anchor point should be closer to the equator. And by making the loading station a mobile ocean base, the entire system could be moved at will, allowing it to maneuver around the extreme weather and dodge debris and satellites in space. Once established, cargo could be loaded onto devices called climbers, which would pull packages along the cable and into orbit. These mechanisms would require a huge amount of electricity, which would be provided by solar panels or eventually even nuclear systems. Current designs estimate that it would take about 8 days to elevate an object into geostationary orbit. And with proper radiation shielding, humans could theoretically take a ride too. So, what's stopping us from building this massive structure? For one thing, a construction accident could be catastrophic. But the main problem lies in the cable itself. In addition to supporting a massive amount of weight, the cable's material would have to be strong enough to withstand the counterweight's pull. And because the tension and the force of gravity would vary at different points, its strength and thickness would need to vary as well. Engineered materials like carbon nanotubes and diamond nanothreads seems like our best hope for producing materials strong and light enough for the job. But so far, we've only been able to manufacture very small nanotube chains. Another option would be to build one somewhere with weaker gravity. Space elevators based on Mars or the Moon are already possible with the existing materials. But the huge economic advantage of owning an Earth-based space elevator has inspired numerous countries to try and crack this conundrum. In fact, some companies in China and Japan are already planning to complete construction by 2050. Well, that's it for today. Thank you so much for tuning into this episode. I guess we'll just have to wait and watch what happens. This podcast is now available on YouTube, Apple Podcasts, Spotify, Google Podcasts, Breaker, and all your other listening platforms. Make sure you subscribe to all of these and write down a review. And then stay tuned for more.